Welcome everyone. We are here today to discuss the importance of thermal properties of matter and temperature and heat, and the relevance of thermometers, scales, and measurements of temperature to ice and steam points. We look forward to exploring this topic and learning more about the science behind it. Temperature is simply a measure of the average kinetic energy of the molecules in an object. It should not be confused with heat, which is a measure of energy being transferred between objects. Heat is not a form of energy itself, but rather an effect of the exchange of energy between objects of different temperatures. Heat is a fundamental characteristic of matter which can be used to measure temperature and facilitate energy transfer between two objects. Energy transfer is conducted through the exchange of heat, where energy is transferred from an object with a higher temperature to an object with a lower temperature. This exchange of energy is an essential aspect of many daily applications, including cooking, regulating heating and cooling in our environment, and producing electricity. Matter's fundamental physical property, temperature, describes a body's hotness or coldness. It conveys the amount of energy present in the matter, and its capability to transfer heat to other bodies it comes in contact with. Temperature serves as an indicator of the matter's thermal energy, stating the direction in which heat will move. It is a significant concept to ponder when contemplating thermodynamic processes. Temperature is an important factor in the study of matter's physical properties. We are aware of temperature and its measurement in degrees Celsius. It is a measure of the average kinetic energy of molecules and atoms that form a material. Different materials possess varied thermal properties, so by measuring temperature we can get better insight into its physical properties. Temperature and heat are two essential qualities in the world of physical science that have a profound effect on the behavior of matter. Temperature is the measure of average energy of the particles, while heat is the energy that is transferred from a higher temperature to a lower temperature. Temperature is measured in degrees of Celsius, Kelvin, and Fahrenheit, while heat is measured in terms of joules or calories. Knowing the thermal properties of matter is essential to understand how it behaves in different temperatures and with varying levels of heat. Answer. The question posed in this slide has an answer of option D. Heat is a type of energy which is transferred between two objects because of variation in temperature. This energy transfer is done through one of three means: conduction, convection, or radiation. Such methods of energy transfer account for the thermal properties of matter. Thermal properties of matter refer to the ways different materials react and respond to temperature changes. These properties include density, temperature, pressure, and surface area. When two objects have similar thermal properties, they are in thermal equilibrium. Gaining knowledge of these properties aids in comprehending the interaction between materials in different situations. Temperature is a crucial physical quantity that can be expressed in two forms: vector and scalar properties of matter. Both approaches are inherent. Temperature aids us to comprehend the dissimilar properties of matter and how they interact with each other. It is further used to calculate the amount of energy existing in a given system. Knowing the distinct thermal properties of matter is crucial in aiding us make sense of the material universe around us. Temperature is a physical property of matter that quantitatively expresses hot and cold. Thermometers are used to measure temperature and it can be expressed in various scales. Calibration of thermometer is based on degrees Celsius temperature scale for accurate measurement. Temperature measurement is beneficial in different areas like food safety, healthcare, manufacturing, and environmental monitoring. Temperature plays a major role in our lives, but many of us may not be familiar with the intricacies of thermometry. A thermometer is a tool made for the purpose of measuring temperature. The word thermo denotes heat and meter is an object used for measuring. Thermometry is the study and the process of measuring temperature. This is significant because temperature is a key element in various scientific and medical investigations. In conclusion, thermometry is an accurate science that helps us gain a better understanding of our surroundings. Thermal properties of matter are being discussed in this slide. Temperature is measured by thermometers with various kinds such as liquid in glass thermometers, constant volume gas thermometers, and resistance thermometers. Temperature is measured using 3 scales: the Celsius scale, the Fahrenheit scale, and the Kelvin scale. When pressure is constant, the change in temperature is given by the change in volume. When volume is constant, the change in temperature is given by the change in pressure. Additionally, the change in temperature is also given by the change in resistance. Thermometers measure temperature by determining how hot or cold an object is in comparison to another object. The zeroth law of thermodynamics states that two bodies, A and B, are in thermal equilibrium with each other if they are both in thermal equilibrium with a third body. See, this law enables the accurate measurement of temperature and comparison to a reference point to determine its value. Through this method, the temperature of any object can be accurately measured and documented. Measurement of temperature is a crucial factor when it comes to getting accurate readings. In order to make sure that readings are accurate, a thermometer must be calibrated to establish certain points. This requires the construction of a specific instrument in addition to calibrating the thermometer. When this is done, it can then provide exact temperature readings. At a normal atmospheric state, a substance solidifies at its ice point and vaporizes at its steam point. In the case of water, the ice point is 0 degrees Celsius and the steam point is 100 degrees Celsius. By taking note of these points, we can observe and measure the thermal properties of a given substance. The ideal gas equation is a representation of the behavior of gases at low temperatures. It is used to compute the volume, temperature, and pressure of an ideal gas. 3 types of temperature are utilized in the equation: Kelvin, Celsius, and Fahrenheit. Each of these are based on the same absolute temperature point, 0, however expressed at different scales. Once one of these scales is known, the equation can be converted to the other 2 scales. Thermal properties of matter involve temperature and heat. An example is the boiling point of water, measurable by the Celsius scale. This scale starts at the ice point of 0 degrees Celsius and 32 degrees Fahrenheit, extending up to 100 degrees Celsius and 212 degrees Fahrenheit with 100 divisions in between, each corresponding to 1 degree Celsius or 1 degree Fahrenheit. Thus, on the Celsius scale, the boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit. At temperatures between the steam and ice points, matter is able to take on a liquid form. On the Fahrenheit scale, the gap between these 2 points measures 180 degrees. This temperature range is paramount for a variety of physical and chemical procedures, for example boiling and evaporation. Comprehending the thermal properties of matter is essential for exploiting its capacity for a variety of uses. Thermal properties play an integral role in understanding matter and its behavior. The ideal gas equation summarizes the interdependence of pressure, volume, temperature and number of moles. In essence, it reveals that these properties are all inversely proportional to each other. This equation is an invaluable asset in comprehending how matter reacts under varying conditions. Today I will be discussing the thermal properties of matter. We know that experiments show that all gases at low densities expand in the same manner. Liquid in gas thermometers, however, show different readings for temperatures other than the fixed points due to their different expansion properties. Thermometers that use gases, however, give the same readings regardless of which gas is used. The factors that influence the behavior of these gases are pressure, volume and temperature, written as P, V, T. The temperature, T, can be expressed as T plus 273.15, where T is the temperature in degrees Celsius. Today, we will explore the thermal properties of matter. We'll begin by looking at how different gases adhere to the relationship of pressure to temperature. At constant volume, a given gas is related to pressure and temperature. This is known as Boyle's law and is represented by a linear equation. We'll then examine the Kelvin scale or absolute temperature scale, where minus 273.15 degrees Celsius is called absolute zero temperature and taken as 0 Kelvin. From this, we can better understand how different gases behave at different temperatures. Today we are discussing the thermal properties of matter. Specifically, we will be looking at how the volume of a given quantity of gas is related to temperature at constant pressure. The Kelvin scale, or absolute temperature scale, measures this relationship, with 0 Kelvin signifying the lowest possible temperature. To calculate the temperature in Kelvin, we subtract 273.15 from the temperature in Celsius. Additionally, the data provided follows the formula of V, T equals constant. These calculations are essential for numerous applications and provide an accurate quantitative measurement of thermal properties. We are examining 3 scales of temperature: the Celsius scale, the Kelvin scale and the Fahrenheit scale. The temperature of ice point is 0 on the Celsius scale, 273.15 on the Kelvin scale and 32 on the Fahrenheit scale. The temperature of steam point is 100 on the Celsius scale, 373.15 on the Kelvin scale and 212 on the Fahrenheit scale. A comparison of the temperature values reveals that on the Celsius and Kelvin scales, the temperature of ice point and steam point is the same. On the Fahrenheit scale, the temperature of ice point is 32 and the temperature of steam point is 212. Lastly, a general formula is provided for converting temperatures from one scale to another. Comparing the 3 temperature scales, the Celsius and Fahrenheit ranges have a much smaller difference between them than Kelvin does with either of the two. On the Celsius scale, water freezes at 0 degrees and boils at 100, while on the Fahrenheit scale, water freezes at 32 degrees and boils at 212. On the Kelvin scale, the absolute zero point is minus 459.60. Thermal properties of matter refer to how material responds and behaves to changes in temperature. Water boils at 373.15 Kelvin, 100 degrees Celsius or 212 degrees Fahrenheit. All three of these can be considered correct answers. Thermometric scales are used to measure changes in temperature. Different scales come with different parameters. For instance, Celsius scale may be used to measure temperatures between -50 degrees Celsius and 1000 degrees Celsius, Kelvin between -273.15 degrees Celsius and 1000 degrees Celsius, and Rankine between 0 degrees R and 2000 degrees R. Thus, the scale to choose from should primarily be determined by the desired thermometric application, along with its related conditions and formulas. Thermometers measure temperature through the use of two fixed points, known as lower fixed point, LFP, and upper fixed point, UFP. The difference between these 2 points is known as the fundamental interval. The ice point is taken as LFP and the steam point is taken as UFP. To accurately measure temperatures, thermometers must be calibrated to these two fixed points. We are examining the thermal properties of matter, focusing on thermometric scales. The fundamental interval is the separation between the highest and lowest fixed points of a thermometer, and it is broken down into equal portions with assigned numerical values, making up thermometric scales like Celsius, Fahrenheit, Kelvin, Romer and Rankine. These scales are essential when understanding the thermal properties of matter, with this slide providing an overview of the fundamental interval and thermometric scales. Equations demonstrate the significance of thermal characteristics of matter when assessing temperature accurately. To be able to measure appropriately in Celsius, Fahrenheit, and Kelvin scales, a faulty thermometer needs to have its lower and upper fixed points established. Having done this, we can then work out the exact temperature reading. At 32 degrees Fahrenheit, water has its lowest fixed point on the scale. This is a widely known temperature at which water freezes. On the Fahrenheit scale, water boils at 212 degrees.